Hey everybody, welcome back. We are going to talk about movables today. Movables are any object in VPX that is separated from the rest that you can move. And the objective of the next few videos is to talk about how to move the VLM objects, so like the bake maps and the light maps. And we'll also be talking a bit about some new features in 10.8 that make animating things a lot easier. So typically, what can you move in VPX? Well, there's the obvious ones like flippers, gates, switches, bumpers, spinners, slingshots, and targets. But you can also move other things like any toy. Movables also kind of apply to options. So say you have a toy that you want to sometimes show or maybe optionally hide, then that toy will be separated from the rest of the objects so that you can individually make it visible or invisible. So it doesn't necessarily need to move, but you can still affect its properties separately. This video will talk about all this stuff in general, and in the next few we'll get into some specifics. Before we really get into it, let's first talk about the coordinate system in VPX. So in VPX, the upper left corner of the playfield is the origin, or it's the 0, 0, 0 position, where it's X, Y, and Z are all 0 at this point. Now X increases as you go right, and Y increases as you go down towards the flippers. Z increases as you go up, so out of the page from this view. Let's go into the table real quick. I'm in the live editor. The live editor is going to be used a lot in this video, and it's really, really useful. I'll post a link in the description with some details on it. But to illustrate the coordinate system, I'm going to press the 7 key on the numpad, and that puts us looking straight down on the table. Then I'm going to go over to this outliner on the left, which is like a tree of objects. And let's type in playfield. And that's going to filter everything in this view for the word playfield. And I'm going to expand the VLM visuals section and click on playfield mesh. So you'll see a little white dot show up in the upper left hand corner. Now this is the origin of the playfield mesh object, which I happen to know is aligned with the origin on the VPX table. So this is the VPX table origin, like I mentioned previously. It's in the upper left hand corner. If I press the G key, it'll bring up some axes. So red is always going to be X, green is Y, and blue is Z. This color combination mimics Blender, and so that's why it's that way. Upper right hand corner is this little cube that you can use to rotate things around. So you can see this would be considered the global axes in VPX. It's important to note that this is considered a left-handed coordinate system. And in a lot of engineering and math classes, you'll typically work with right-handed coordinate systems. In Blender, for example, everything is in right-handed coordinate systems, and there needs to be a transformation to left-handed coordinate system when all the objects are exported from Blender into VPX. All that stuff is handled automatically by VLM, but let me make sure you guys understand what I mean by left-handed and right-handed. Here you can see the difference between left-handed and right-handed coordinate systems. Your hands are just used to mimic the axes, where the thumb is pointed in the X direction, index finger in the Y, and middle finger in the Z directions. You can see the difference between the left-handed and right-handed is really that the Z axis gets flipped. In VPX, like I said, we're using the left-handed system, so imagine rotating your hand around your thumb to point your index finger down. When you do that, your middle finger will be pointing towards you. So that mimics the global coordinate system in VPX, where Z is pointed up away from the table, Y is pointed down towards the flippers, and X is pointed to the right. On the right side of this picture, you can see like a thumbs up symbol. And this is using your left hand again, because we're in the left-handed coordinate system in VPX. Point your thumb in the direction of any axis, and then your fingers are going to be rotating around the axis in a positive angle direction. So this helps you to find what positive angle is. So say you're pointing your thumb in the Z direction, which is up away from the playfield. Increasing angle would move objects clockwise in that case. So we talked about the global frame in VPX, but there's a bunch of objects in the table, and each object has its own frame. When an object is created in Blender, it's created within its own frame of reference. And so when it's imported into VPX, it comes in that same frame of reference. For example, I'm going to look up switch 20, which I happen to know is this little combo target on the left side of the playfield. When I select it, the frame moves to be centered at the origin of that object, and it's rotated to be pointing in the direction that we've defined by some transformations that we've applied to it. So how did we place this object here and in this orientation? Well, the object has a bunch of properties that define where it is in space and how it's oriented. You really have to understand how those properties work in order to position the object in VPX. And these properties can be updated in real time, so this allows you to animate the object. All right, let's dive into those details. Coming back to the table, I'm going to search for switch 20 again. And I'll select on the bake map and zoom in. There it is. When I select it and go to the position tab, you can see all these properties here. These are the ones that are used to define its position in space and its orientation in space. There's a lot of numbers here, so I'm going to go over each one and describe how it applies to the object. Here I've zoomed in on the property pane that you see in the table editor on the left, and on the right are the same properties, but this is how you view them within the live editor. So I'll be doing some modification of the properties in the live editor, but just know that they're equivalent to the ones that you see in the table editor, and the relationship between the two editors are highlighted here in colors. When I describe what's going on, I'm going to refer to these properties by the names used in the table editor, because these are also the names used in the script. So if we want to affect any of these properties through the script, we're going to be using the names shown in this pane. Each one of these numbers are applied to the object in a certain sequence. And order matters when doing these transformations. So step one is the trans X, trans Y, and trans Z position transformations are applied. So this is moving the object within its own frame by a certain amount in each direction. The order in which you apply trans X, trans Y, and trans Z doesn't matter. It's kind of like, moving forward and moving to the right. That's the same as moving to the right and moving forward. You end up in the same position. But in the next step, what we're doing is rotating the frame along global axes consecutively. In this case, order definitely does matter. And the order that VPX uses is shown here from left to right. So the very first rotation that's done is rot Z. Then the result of that is rotated along the y-axis using rot Y and then rot X. Again, all of these are done along the global axis directions. Once rot X is done, we jump down to object rot Z, then object rot Y, and object rot X. I will demonstrate this in the live editor, but just know that this sequence is important. And finally, once all the rotation transformations are done, the entire frame is moved to a certain X, Y, and Z position within the global frame of reference. Back in the live editor, we're looking at the combo target again. I'm going to use this target as a means to explain how the transformations are applied to any object in VPX. Before I do that, I wanted to point out that if you press the G button, it'll toggle the axes to point either in the global direction or in the direction defined by the transformation you get from rot Z, rot Y, and rot X. So really that's just kind of a visual thing to help understand how the first set of rotations are applied to the object. For the purposes of the transformations, what matters is the direction of the global axes, and that's what's shown in this view here now. Okay, so let's set all of the object's properties to 0 and see what happens. I'm going to set X to 0, Y to 0, Z to 0, and then the rotation to 0. You can see that the object moved to the upper left-hand corner of the table, which is the origin of the global frame. If I press the period key on the numpad, the view centers on the object I have selected. So it makes it easier for me to kind of rotate around it. I'm going to press 7 on the numpad to get a top-down view. And here I'm just going to illustrate how the transformation and rotations get applied. First, let's talk about the rotations, because the rotations are applied in a specific order, and I want to illustrate what that means. So let's rotate this target positive 90 degrees along the x-axis. So remember, we're in the left-hand coordinate system. If I point my left thumb in the direction of the red arrow, which is the x-axis, my fingers are moving in the positive angle direction. So if I put 90 here, you can see that the target is rotated 90 degrees along that axis. Let's put that back to 0. Now, if I do 90 degrees in the Z direction, so thumb pointed out of the page, there we go. So what if I want to combine two rotations? So I just rotated in the Z. If I rotate in the X direction, again, my thumb pointed in the direction of the red arrow, what do you think is going to happen? Yep, the target tilted as expected. So now it's laying on its side, essentially. So putting everything back to 0. I'm going to do this one more time where I'm going to rotate along the X direction first, 90. The combo name is pointed up. If I use rot Z to rotate along the Z direction, you would expect that the second rotation would result in being able to still read combo, but that the combo word would be rotated 90 degrees. So let's use rot Z and try that. Nope, that's not what happened. That's because rot Z gets applied first and then rot X gets applied. So let's put rot Z back to 0. if we want to achieve the case where we rotate along X axis first and then we rotate along the Z axis second, well, we'll have to use the obj Z, which follows rot X. So I'm going to apply a 90-degree rotation using obj Z. And there we go. That's the expected result when you do first a rotation along X and second a rotation along Z. Note that this also illustrates that all of these rotations are occurring around the global axes. Now, putting all the angles back to 0, remember the very first step is that we translate the object within its own axis using the trans X, trans Y, and trans Z values. So that would be these numbers. I'm going to translate along the y-axis, say 20 units. And then I'm going to rotate along the z-axis using rot Z by 90 degrees. That's expected. We can do an additional rotation using obj rot Z. Let's do another, say, 45 degrees. So you see it's just consecutive rotations in the Z direction, but it's after the trans X and trans Y and trans Z were applied. And finally, let's move the whole origin a little bit in the X and Y direction. So I'm going to move, say, 50X and 40Y. So hopefully you understand a little bit about how these properties are applied and in which order they're applied. And once you understand that, then you can start using them to move objects around dynamically. So what's a practical use for all this stuff? Well, in the case of this target, when a ball comes up and smacks it, the target's going to move backwards. What we want to do to achieve this effect is to translate the target in the negative y direction and then rotate the target such that it's pointing in the direction that it should be on the table. So trans y gets applied first, then rot Z gets applied. I'm going to toggle the frame to show us what it looks like when rot Z, rot Y, and rot X are applied. So we know that if we do a trans Y motion, it's going to go in the negative direction along this green arrow. So I'm going to apply minus 10 units using trans Y. So this is probably what we'll want to do in the script to simulate deflection of the target when the ball hits it. Back in the table editor, we're looking at SW20. This is the bake map, but I want to also show all the light maps too, and I'll select all of them. Going to the position tab, I'll put a minus 10 into trans Y, and you can see them all move together. This is exactly what you would want to do when the ball hits that target. So how would we do that? Well, we need to have access to all of these objects really easily within the script. And if you remember back from the very first video, we talked about the VLM arrays. So if I go over here to the script and I search for SW20, I find this array called BP_SW20. Within the array are all of these objects related to switch 20. So BM being the bake map object, and LM are all the light maps. So this array contains basically everything we've selected over here on the right. In order to move these objects in the script, we will have to loop through each of these objects in the array and modify the object's trans Y property. Okay, let's see in the script where we're actually doing that. All right, I'm going to get into more details on how this all is set up in a following video. for targets, but just as an example, here is the line of code where we loop through all the objects in this array, BP switch 20. So for each BP, where BP is a variable, in BP SW20, which is the array, update that object's trans Y property with some value, and then do the whole thing. You'll see this for loop structure all over the place when we're doing these animations. Targets are a special case because they utilize the Rothbauer code. So they don't utilize the new 10.8 animate callback. So let's go to a different object where we get to use the animate callbacks. Probably the best one to look at is the flippers because they're so familiar. So I'm going to search for the flipper animation subroutine. The _animate callback is something new in VPX 10.8. It really simplifies how we animate a lot of the objects that typically move. The animate callback will be called whenever the object associated with it changes position or rotation. So it really makes it easy. You just assume that things are changing when it's getting called, and you're just updating whatever you need to when that callback is called. So for the flipper, we first grab its current angle, and in this case we're updating the flipper shadow object. And here's that for loop structure that we saw before on the target. So we're looping through the BP flipper array, which includes the bake map and all the light maps on the flipper, and updating its rot Z property, because the flipper is going to be rotating, clockwise and counterclockwise on the table. I'm just going to zoom out and look at the left flipper real quick. All right, so here's the left flipper bake map and light maps. Just as a test, I'm going to go up to the position tab and update the rot Z property. You see there's already a value in there. So I'm just going to modify that. I'll just say it's going to rotate. If it rotates up, it's going to be counterclockwise, which means negative change in angle. So it's at 119 now. I'm just going to make it at 100. I'll rotate it up a little bit. I'll put it back. Okay, well that about covers the intro to Movables. On the next video, we'll talk about specific objects and how to set up their animation subroutines. See you then.